This is the magnetic field of a permanent dipole magnet lab. And the problem here is that I need to find the distance dependence of a bar magnet's magnetic field by testing different values of R and then compare a computational value of the magnetic field with an experimental value of magnetic field. The results are that a stronger magnetic field is seen at closer distances, and overall this experiment is proof of the orientation of a magnetic field of a dipole. The sections, we will go over the model and principles that set up this lab, as well as the experimental procedure and computational outcomes. So the experimental model used here is that the magnetometer on my phone was used to record data. And as you can see in this image, 2 rulers were used for the distance dependence part, but various values of the x component of the magnetic field were tested, which is what allowed me to record distances and therefore show the distance dependence. And the x, y, and z components were also tested to find net magnetic field for the off-axis field. And then the computational model set up on and off-axis arrows of magnetic field, and this was scaled to test against experimental data. The principle used in this lab is the Biot-Savart law, which is used in electromagnetism to describe the magnetic field generated by constant electric current. So here I can use it for calculating magnetic field of a permanent dipole, and the formula allows me to relate magnetic field to a measurable quantity, which is distance. The experiment, so various values of R were tested, and the distance that each value was seen at can be seen here. And then at the bottom, pretty much the same thing was done, but for the off-axis field, so taking into account the x, y, and z components of magnetic field. N was equal to negative 3.2283, or the slope of the line, and as the magnetometer moved closer to the magnet, the measured x component of the magnetic field increased, as can be seen in the experimental data. And then when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. So the coding, first I had to set up a function that would calculate the magnetic field of the dipole, and then the axis of each observation location was created, along with each arrow on and off axis of the magnetic field, and then the 45-degree magnetic field was calculated and printed out. As you can see here, there are 2 on-axis arrows and 4 off-axis or perpendicular. And down here we can see B at 45 degrees was about 1 times 10 to the negative 5th, 3 times 10 to the negative 5th, 0. So what if I did not compensate for magnetic north? How would it change? The results would be different because another field besides the magnet would have been factored into the calculations. And if I had stuck 2 magnets together and ran the experiment again, would the measurements differ? There would be variation because the magnets together would have a stronger magnetic field. So in conclusion, magnetic field is distance dependent. The Biot-Savart law can be proven using a simple experimental setup, and there are magnetic fields everywhere.